Hey everybody, we got an upcoming test coming here at my school, so this is our review for modules 3 and 4, our Unit 2 test. So first of all, good luck on your test. I hope this lesson helps you quite a bit. So this is set up to mimic your upcoming test. So you have questions that look just like this on your test. What's the value of f of x equals 3/8 x plus 3/5 if x equals 24. So I'm going to put in 24 right there. Okay, so when we do that, we get that. And then notice this 8 goes into 24 three times, so that we'll cancel that. And then we'll do 3 times 3. 3 times 3 equals 9. So 9 plus 3/5. And you can just write it as 9 and 3/5. Okay, if your teacher wants you to convert that to an improper fraction, then it would be 5 times 9 is 45. 45 plus 3 is 48. So 48/5 would also work, okay? Either way. So bathroom has 10 gallons of water, so each minute. After that, 3 gallons are poured into the tub, so I'll write a function in terms of WT, which is the water with respect to time that represents this situation. Okay, so since it already has 10 gallons in it and it's getting 3 gallons each minute, so we'll do each minute is going to be our time, so 3t, but we already have 10 gallons in it, so it's going to be 3t plus 10 is going to be our function, okay? All right, so which function situation would have a discrete graph, and circle all that apply? Okay, remember a discrete graph is it means you can only you can count them. They would give you points onlys. Otherwise, it's continuous. So, for example, the number of textbooks in a classroom. Can I count the number of textbooks in the classroom? Excuse me. Yes, I could. If I was in the classroom, I sure could. How about, can I count the amount of water in a bottle? No, I can't right there. So that one is called continuous right there. How about the heights of students from age 10 to 15? Can I count that? No, that would be a continuous function. So if we graphed that on a straight line, it'd just be a line right there. Otherwise, the shelves in a classroom, I can count the shelves in the classroom. So those are all the discrete ones right there. The number of textbooks, the ones that I can count are discrete ones. Okay. All right. So let's sketch a graph of this situation. So let's see. So we got home right here. We got time right here, and it says John ran to the office for 4 minutes. And then, so I'm guessing he's at home right now, so he's down here at home. So he ran, so his speed is going to go fast, so it's going to be a steep line for 4 minutes right there. Let's go ahead and do that. Okay, let's put in the minutes right there. I'm just adding up. 4 plus 8 is 12, plus 20 is 32. And it's actually going to be more than 32. I'll show you in just a second. So here's John running for 4 minutes. Okay, how steep? I don't know. Steeper than when he walks. When he walks, he's going at a slower pace, so he's going at a slower distance over time right there. So here he is. Here's 8 minutes. So for 4 minutes he ran to the office, and so for the next 8 minutes right here, he walked to the office. Now he stays at the office for 20 minutes. So that's just going to be his distance away from home is going to be the same for 20 minutes. So that's going to be 5 lines because all of these are going by 4s. So 1, 2, 3, 4, 5. So he's gonna stay at the office. So there's going to be a horizontal line right there, and then he runs home. Okay. How long does it take him to go run home? I don't know. So, but if he's running at the same rate as he ran over here, it's going to be about the same steepness right here. Okay. So the graph shows Julie's distance from home. What does each letter represent? Okay. So we just did something like this. So this one looks like Julie might have walked. Julie might have ran. Julie might have had a meeting or something right there. Okay. Something like that. Okay. All right, so these are questions you're going to see just like this on your test. So what is the common difference between the terms of this sequence? A sub n. Now, my students we've been writing f of n with parentheses, but a sub n is the same thing, okay? So f of n equals negative 8n plus 11. Well, if you don't know, then just plug in the first term, the second term, the third term. So a sub 1 is going to be negative 8 times 1 plus 11. And it should get us 3. A sub 2 is going to be negative 8 times 2 plus 11, which is negative 5. A sub 3 is going to be negative 8 times 3 plus 11. So it's negative 8 times the term plus 11. And if you don't see a pattern yet, here we go. A sub 4 is going to be negative 8 times 4 plus 11. So here's the sequence right here. So it's going to be, if we kept doing that, it gets us that. And there's our sequence right there. So there's our D right there. So that is our common difference. D equals negative 8. And it's always that number right there. Okay, so if we saw A sub n equals, say, 15n minus 33, then D would be 15. Okay, all right, so there you go, Lucy. I got my little dog. She wants to play with me. What's the value of f of x equals x squared minus 7 when x equals negative 9? So let's plug in negative 9 right there. So since it's being squared, we've got to wrap the negative 9 with parentheses and square that. So negative 9 times negative 9 is 81. 81 minus 7 is 74. Okay? All right, these are just like what you're going to have on your test. So state the domain and the range shown in the mapping diagram. Okay, so this is typically our x's, this is our domain, and this is typically our y's. That's our range right there. Now, it might ask you on the test, is this a function? And so if it's a function, if every x goes to just one y. Negative 2 goes to 5, okay. Negative 1 goes to 3. 0 goes to 5, that's okay, because 0 only goes to 1 y and 18 goes to 3. So that, yeah, that is a function right there, because every x value goes to only one y value, okay? We just can't have x's going to the different y's. So if I had like negative 2 up here to 7 right here, it would not be a function, and the x's can't repeat. Okay, what's the 10th term of this explicit rule? So we're going to plug in 10 right here and make it 10 squared over 5 times 10. Okay, so 10 squared is 100. 5 times 10 is 50. You should get 2. Okay. All right, is this relation a function right there? So look to see if there's any x's repeating. 3 goes to 5, 6 goes to 7. Uh-oh, 6 goes to negative 8. Okay, so right here, because 6 goes to two different outputs, it's not a function. So no, it's not a function, okay? All right, so write this in function notation and let y be the independent variable. Okay, this sentence right here is just to throw you off a little bit. Function notation is f of x. So we'll just write f of x equals that stuff right there. Remember, y equals f of x. So f of x equals the function right there, okay? All right, so Bob bought a car for $48,000. Each year, the value of the car decreases by $1,400. Write a function that shows the value of the car after X years. Okay, so it starts at 48, so that's where we're going to start at, and then each year it's going to decrease at 14,000 or 1,400 bucks. So X is the number of years right there. Okay. All right, so let's graph this function for the domain. Okay, now our domain is restricted to just these X values, so we got to plug in negative 4 right there, negative 2 next to the X, and then 0 next to the X, and then the positive 2 next to the x. Okay, so this 2 right here goes into negative 4, negative 2 times, and so you'll see I'm canceling that. So here we have negative 3 times negative 2 is a positive 6. 6 plus 2 is 8. Here we have negative 3 times negative 1 is positive 3. 3 plus 2 is 5. So anyways, we get those y values. So we're going to graph these ordered pairs right here. So to the left 4, up 8. So to the left 4, up 8. Well, here's 7. So I'll just kind of guesstimate right there is 8. And then to the left 2, up 5, and so on right there, okay? So we get those right there. And then so why do we not connect those points on that graph? Well, because they restricted our domain to just those x values. So we can only graph those ordered pairs right there. If it just said graph this function right there, then I would connect them right there. And I think that's what's coming up right here. Yep. So graph this function. So let's just write. So this one we're going to connect all the points. Let's write an x. We'll just pick some x's, negative 3 through positive 3, and we'll plug them in right here. So let's do that. So negative 3 squared minus 2. negative 2 squared minus 2, all of these x's, minus 2 squared minus 2. Alright, so negative 3 squared is 9. 9 minus 2 is 7. This is 4. 4 minus 2 is 2. And then 1 minus 2 is negative 1, and so on. So now we're going to graph negative 3, 7, okay? So there it is, negative 3, positive 7, over 3, up 7, negative 2, up 2, so over 2, up 2, negative 1, negative 1, so to the left 1, down 1. Here's 0, negative 2, and then here's the other side over there. And this is going to be graphing a parabola, and we'll talk more about that later, okay? Parabola, it's a parabola because it's being squared right there. Anyways, there's our graph, and we connect them all right there because it did not ask us to restrict the domain to just some certain x's. So what's the value of this function when x equals negative 7? So we'll plug in negative 7 right there. So negative 7 squared is 49. 49 minus 2 is going to give us 47, okay? So we couldn't graph that, but if we did, it'd be over here and then way up there at 47, way off the chart right there. Alright, so find the next 3 turns of this sequence. So let's see what this sequence is doing, okay? So from negative 4 to 1, looks like it's going up plus 5, yep, plus 5, plus 5, so it's going up plus 5, so that's our D right there, our common difference, so we just keep adding 5. Okay, so our next term is 11 plus 5, or 16. 16 plus 5 is 21, then 26. There's our next 3 terms. Alright, write an explicit rule for this sequence. Okay, looks like this one's going up plus 9, plus 9, plus 9. Can you see that right there? So that's our common difference is plus 9, and our first term is negative 8. So we just plug it into this formula. Negative 8 goes right here. Plus n minus 1 times, in this case, 9. Our common difference is 9, okay? Distribute the 9 through and then combine like terms, and there we go. Alright, it might ask you, after you find the explicit rule, find a certain term in that sequence. Here it says find f of 17, so I'm going to plug in 17 right next to that 9 because that's where the n is, okay? And if I did my math right, I get 136. Alright, you guys, I hope you guys do fantastic on your test. Take care.